I'm Carolyn Lowe. I am the director of the Central Florida Tech Grove, located in the heart of the modeling, simulation, and training industry in Orlando, Florida. I am delighted to be your host once again for our NTSA Tech Growth Connect webinar series. For those of you that have not joined us in the past, we do this each month for a period of 7 months, featuring the teams and the stories behind the best papers from the previous ITSIC. We'll have a couple of more webinars this year, and then we will resume our series next February, featuring the best papers and tutorial, actually, from ITSIC 2022. First, just a few bits of information about the Central Florida Tech Grove for those of you that may not be familiar with us. We are a fairly new, very innovative hub here in Central Florida, physically and virtually, that is unique in that we support not only multiple DoD services, but also multiple agencies. We were created about a year and a half ago by the Naval Air Warfare Center Training Systems Center here in Orlando that executed a partnership intermediary agreement with the University of Central Florida Research Foundation. From the very beginning, however, we were funded as well by the U.S. Army's PEO STRI, the U.S. Marine Corps PM TRACIS, Air Force Agency for Modeling and Simulation. In the recent months, the Army Futures Command Synthetic Training Environment and the U.S. Army's Simulation and Training Technology Center have also joined us as customers. And there are just a few pictures on there of some of the many diverse activities that go on in Tech Grove, and we do stay pretty busy. These are our focus areas that probably are not unknown to most of you on this webinar. AI, of course, machine learning, XR, VR, which this webinar certainly will touch on deeply, LVC, STE, and along the bottom there, because we often are trying to explain to non-traditional audiences, entrepreneurs, innovators, academicians who are not familiar with this world, what is modeling, simulation, and training? What comprises that? So along the bottom, you see some of the enabling capabilities and technology areas that we are reaching into those clusters across the country, actually, to identify innovators that could bring their solutions to the table for our customers here at Tech Grove. We hope that you will connect and engage with us beyond just attending this webinar. We do a lot of other things. I invite you to follow our LinkedIn page, which is pretty active. Our website is in the process of being updated. So I apologize, it's a little bit outdated. But the one thing I would like you to do while you're on the webinar or afterwards is go to the Connect with Us page, fill out that contact form there, and we will be able to get you right into our database and send you periodic, not frequent, but periodic emails about key events that we have coming up and opportunities for you to engage with us. And check out our new YouTube channel. What you will find up there are all the videos from the companies that presented at our recent SBIR Partnership Day, which was on June 30th, as well as the other information sessions there. But now on to the reason that you are all here this morning, and that is to talk to Dr. Claire Hughes from Design Interactive. And Frank is with us as well, who was with the Defense Health Agency. And Frank Kurlick was the project manager on behalf of DHA, who has worked very closely with Design Interactive. Their bios are on the NTSA Tech Connect website. Hopefully you've had a chance to see those. So the way this is going to flow this morning, Dr. Hughes is going to go through a presentation about the work that they did that resulted in the best paper at ITSIC. We do have some questions that some of you submitted beforehand. Some of those will be answered by her presentation. Others that were not, we'll try to get to it after her presentation during the Q&A time. And please do put your questions in the Q&A section of the webinar platform if you have others that you would like to ask along the way. With that, Dr. Hughes, I'll turn it over to you.
Well, good morning, everyone. Thank you for joining us today. So here to talk about augmented reality and tactical combat casualty care and the physiological ramifications of using some of these immersive technologies. So we always like to start off with our quote from Dr. Darren Fry, who's the Health and Science Administrator of the Expeditionary Medical Skills Combat Casualty Care Research Program at JPC6. He says that we not only need to determine what innovative augmented and virtual reality technologies can do for us, we need to understand what they can do to us. That's a very, very poignant statement, and it's 100% true. So the question is, why do we need to understand what the physiological impact of XR technology? Widespread adoption of these technologies might be hindered by potential adverse physiological effects. We know from 30 plus years of VR research that VR has a very stable amount of physiological impact. It can be quite profound in certain individuals. It often leads to dropouts. And there seems to have been an assumption that AR is just VR's benign counterpart. You can see through it, so you have real world rest frames, and that this isn't going to cause any problems in your physiological state. However, our study that was presented by the opportunity to run the research study was presented by JPC1. We actually did find some concerns for prolonged hand-eye coordination degradation, and this could impact our operational readiness. It's not a safety or accessibility issue, it's not an accessibility issue, but it is a safety issue. So while the VR usage protocols have been well developed over years and years of research, we still need to do more research into the AR world to really fully understand how these types of technologies are affecting the human from a physical standpoint. So let's just talk a little bit about accessibility. So again, 30 plus years of research into the VR space that Dr. Kay Stanley, who unfortunately wasn't able to be with us today, she's been doing this research for, like I said, decades. Very consistent dropout rate of around 13%. The longer the exposure, the higher the dropouts. Very consistent rate of emetic response. For those of you who don't know what emetic response is, it's vomiting. Very consistent 1% rate. Dr. Stanley gets called in to lots of locations every time they're cleaning up vomit. And so we've done lots of research in the entertainment space and the medical and the DoD space into some of these responses to try to reduce these effects, mitigate them, and make these things safe for long-term use. So what we know is that VR can be physiologically self-limiting. People tend to drop out when they start to not feel well. With augmented reality, that's not the case. We ran over 450 participants. We had not one single dropout, not one episode of vomiting. So it's definitely not self-limiting. You're not going to start to feel poorly and back yourself out of the experience. So no particular accessibility limitations that we're seeing with AR. From a severity standpoint, and I'm not going to get into all of the details of all of these numbers here, but from a severity standpoint, the AR head-worn displays are much lower, much more low to moderate symptom severity, probably why we're not seeing dropouts. They also have a different symptom profile, and we'll talk about that a little bit in just a little bit. VR tends to cause a lot of disorientation and nausea. However, AR causes more strain on your ocular motor system, headaches and eye fatigue, etc. So I knew I was going to talk about it. Here it is, my next slide, the subjective symptom profile. So VR legacy systems from long time ago, you can clearly see have a very clear disorientation, more than nausea, more than ocular motor. So they have what we call a DNO on the Simulator Sickness Questionnaire symptom profile. Current generation head-worn displays, same symptom profile. AR head-worn displays, very different. This is higher ocular motor, lesser disorientation, and very little nausea, which is why it's not self-limiting. And this slide gives an example of how the symptom profiles are much more broad for VR versus AR. So the worst symptom for AR is fatigue, headache, general discomfort. With VR, you see symptoms all across the spectrum of the simulator sickness questionnaire. Symptom severity. So again, a lot more folks in the low to moderate range, a lot more folks in the none range. We have quite a number of participants who have no symptoms with AR, but we do still see some of these folks over here on the far right-hand side in that extreme category. The most interesting thing that we found with AR and VR is that there was an inverse relationship to the exposure duration. So with VR, we've known for a long time that the longer you're in, the more sick you get, the more likely you are to drop out. With AR, we thought that it would be very simple exposure protocol. You get in, take a break, get out, and repeat that exposure duration for a period of a total exposure of 2 hours, and that you would be totally fine. Just hop in and out, back and forth, and your system wouldn't be compromised. But that actually wasn't the case. That was actually worse for folks. The length of the breaks in between caused higher symptom profiles and higher cyber sickness. From a physiological perspective, subjectively, staying in the headset for a straight 2 hours was actually more less physiologically perturbing. But as we'll see as we get a little further into the data, that's where we see the potential safety concerns with hand-eye coordination being disturbed after that full 2 hour exposure. So there are also sex differences. It matters more in VR than AR. It actually turned out in our data set that it looked like males were a little bit more susceptible in AR than they were than females, but that may be a product of a much smaller sample size in AR. Also potential confounding variables with vision correction. We haven't had a chance to dig into the differences between folks who wear glasses, don't wear glasses, those who wear glasses, don't wear glasses but maybe should, those who wear contacts. So there's definitely some things going on with an AR situation where as the way it potentially compromises your vision. I think that more research will find that if we dig into those things, we're gonna get more information. So those are kind of future follow-on efforts that we could do. As far as the assessment of physiological impact, everything we've talked about so far has been your subjective physiological impact. It's been measured by your SSQ. How are you feeling when you get out of the exposure? But we also do an objective assessment. So we have three tests which are kind of related to the roadside battery. So we have for a sobriety test. So we have an hand-eye coordination test where you're similar to bringing your finger to your nose, how much you're off in a three-dimensional space with your felt limb position. Potential modifications to VOR gain and visual functioning. We're looking at eye tracking for that. And then postural instability. How stable are you on your feet before and after you're out of the exposures? So as we go through from an objective perspective, VR hand-eye coordination and postural instability tend to be very long, very prolonged after exposure. It sometimes doesn't even recover after 2 hours after exposure. You're still potentially perturbed. AR is a little bit different. Our hand-eye coordination never recovered. Our postural stability recovered very quickly. Again, we have those real-world rest frames, so we're not feeling that disorientation and nausea potentially. However, the real concerning factor here was that with a full 2-hour exposure in the head-worn display with no breaks, we did see a substantial shift in their hand-eye coordination between their eyes open and their eyes closed. And what we found was that after 2 hours in the head-worn display, you were actually better at a pointing task with your eyes closed than where you were with your eyes open. So your vision was so perturbed that your felt limb, your own proprioception of where your hand and your arm were better without your vision than they were with it. So that's the biggest safety concern that, of a potential concern, especially to the government, if we're talking about sort of an IVAS headset where we're expected to wear this for a very long time. What's going to potentially happen if we take it off and then have to do, fine motor tasks or infantry, shoot, you got to go shoot at something. Is your vision going to be compromised if you've been in that headset for too long? So getting into some of the gut activity after effects. Again, we did not see the nausea component in AR like we do in VR. You can see that there are, from these graphs, you can see that there are minor amounts of changes between baseline and the different exposure protocols, but really nothing compared to VR. So we're not expecting AR to affect you in the gut region. So some of the things that we've learned, VR has been studied for years. We have numerous usage protocols, keeping your exposure duration short, using intersession recovery intervals until you're used to how the VR affects your system, using headsets with adjustable interpupillary distance range. So this is one of the interesting findings from a few years ago. Is we did a study in sex differences for VR. And what it came down to was that women have a tendency to have a smaller interpupillary distance, the distance between their eyes, and the headsets themselves didn't accommodate for that. So the many head-worn and a lot of head-worn displays have changed things over the years. And so we're getting close to not having those sex differences, but those of us ladies who have smaller IPD and are potentially susceptible to motion sickness, be careful in VR, girls. That's how it's going to work for now. AR, we don't have the IPD restrictions with the AR head-worn displays. The current generation head-worn displays account for all IPDs. But what we are finding is that the exposure duration potentially matters in AR, but we have not established what the right usage protocol is yet. Future research is needed for this to really fully understand how your body adapts to the AR headset and how you what the appropriate protocol is to get you used to it. One of the things that we've come up with is that it's possible that AR head-worn displays function similar to a new prescription for your glasses. What does your doctor tell you when you get a new prescription for glasses? Wear them and keep wearing them until you get used to it. Maybe that's what a head-worn display is similar to. Maybe we need to get in that thing for 4 hours, a couple of times, 2-3 days in a row, and then we're going to get to a point where we're used to it and we can pop it in on and off without having any problems. But we just don't know that yet. That's one of the things that we want to dig into in a future effort. Another thing that we can do, one of the things that we would really be interested in doing moving forward, developing some of these design guidelines and usage protocols, but we can do these in the field. We want to run some experiments out in the field and assess how those physiological differences are potentially different from the lab if you're actually using the head-worn display in an operational environment. And then once we've kind of done that, we want to take it back into the lab, and using some of those real-time safety metrics, using some of those assessments, we want to develop real-time algorithms based on the accelerometer, the gyroscope, and the magnetometer within the headset, and see if we can actually determine in a real-time way whether you're at risk. So if you're kind of wobbling around, we know, hey, slow down, you need to take some time and take a break. So this is just a little list of kind of all the publications and awards that we've done based on this research. And from there, we'll start the discussion. Carolyn, I think you're muted.
Sensitive button. Sorry about that.
No worries.
Wanted to give Frank a chance to comment on your presentation. Frank, since you were the project manager for DHA on this, maybe a little bit of background about why this particular study was funded, tactical combat, the training here is, from what I understand, mandated DoD-wide. Pretty much all the services have to offer this, so understanding an effective way to offer this is pretty critical. But a little bit about your perspective on this.
Sure, it is. It's a very important principle, understanding the safety concerns surrounding this. And just going right back to Claire's first slide with the quote from Dr. Fry, we not only need to determine what innovative augmented and virtual technologies can do for us, we need to understand what they can do to us. That really resonates. And I believe Dr. Fry is on the call, and he's probably blushing because we're quoting him so many times. But if we think about that, the technology we want to make this training or this simulation as realistic as possible. And the closer we get to being real, more and more bad things are going to happen, both physiologically and psychologically. And understanding how AR and VR change the way our bodies and our mind operate once we come out of that, or even while we're in it, is very important. So the one thing that I wanted to share was a personal experience. I'm not directly AR, VR related, but into that full immersion simulation, which just adds another dimension to what we're concerned about with AR, VR. So it's extremely important to understand these things and how it affects our mind and our abilities. And then we take into consideration the next piece, where if we put a service member with post-traumatic stress disorder into a scenario, how is it going to affect him or her differently based on their experience? So the example that I wanted to share, like I said, it's not directly AR, VR related, but we were trying to get as close to virtual reality as we could at the time. So I tried to estimate how long ago it was, and I'm thinking it was around 2011 timeframe at a medical simulation training center, also known as the Mystic, which is an Army-funded effort for simulation training. And the goal was to immerse the learner into a situation while they're doing TC3 and make it as realistic as possible through sight, sound, vibration, sense, every way we could overwhelm your psyche and make you feel that scenario is real. So in this particular case, we had a seasoned medic. He had 3 deployments. He was a senior NCO, saw some very traumatic things take place overseas, and we knew that going in because he did help provide the didactic instruction during the training event. So we brought him and his squad into a sim lab, immersed them into a TC3 scenario, and it was a matter of seconds. And this NCO froze, fell to the ground, became very diaphoretic or sweating, and we noticed he was starting to shake and tremble. So I was the senior instructor during this particular event, so I recognized it. shut the scenario down, pulled everyone out of the sim room as quickly as possible, as not to cause him any embarrassment in front of his people for what was going on, but mainly to make sure he was okay. And in that little bit of time it took to pull everybody out of the room, I got back to him. He was on the floor. He had stripped off all of his tactical gear, and he was laying in a fetal position, shaking. So while trying to comfort him and bring him back to reality, even though we were not in virtual reality or augmented reality, in his mind, he was already there. He was in a different world. One of the other instructors sent for a mental health professional that was on the installation to help with this. It actually took a couple hours to bring him back to reality and bring him back from that situation. So after talking to him, it was the scent. There was a scent in that room that triggered him. And based on memory, it's hard to say. I believe we were using just fire and gasoline as a background scent because there was supposed to be a firefight taking place. So we had these little scent generators, which are like those Febreze air fresheners you get for your house, except you can buy all kinds of off-the-wall scents for them. And that particular scent, when we started talking to him and found out why it triggered him, one of the events that he was involved in overseas was his convoy was ambushed, and he had to pull members of his team, which he knew very well, out of a burning vehicle. And unfortunately, many of them succumbed to their injuries. So that smell of the fire and the gasoline is what put him into that situation. So then years later, thinking about it, with traveling, just normal travel for me, going to different events, whenever I'm walking down a jetway and I smell jet fuel, I immediately think about my time in Afghanistan. And thankfully, in my case, it doesn't bring up traumatic cases, but just that little bit of exposure to that scent reminds me of my time working as a medevac crew member. So thankfully, mine's at a much lesser scale. But when we talk about AR and VR, this took place pre-augmented reality and virtual reality. So all of the stuff that Claire pointed out and how we need to understand how it affects the learner, the PTSD aspect becomes very relevant to add to those or compound or exacerbate all the things that Claire pointed out, because we can't predict those. We don't know what's going on in the learner's mind. We don't know what they've been exposed to. So this becomes an increasingly important aspect to look forward on and make sure we do continued studies, because as we advance these capabilities in making simulation realistic and as realistic as possible, we can now place the learner back into that very traumatic situation just by the press of a button. And that's very scary. So that statement, I'm going to reference it again, that Dr. Fry made, make them blush again. It really does resonate and points out something that we need to look at in all future simulation efforts, and especially augmented and virtual reality, because not only are we causing these different things to take place within the body, but what are we making take place in the psychological aspect? And there's other studies, which I'm sure Claire will talk about at a later date, which are more centered on that. But that's the scary thing for me, just not knowing what that person was exposed to, what we might trigger. So I thank you very much for this opportunity. And I think these are really great opportunities going forward for these short webinars. Thank you.
Thank you for being here, Frank. And Claire, I appreciate that you're responding to some of the questions in the Q&A. And as I mentioned, we do have some that are pre-submitted. I want to inject, though, here, that thinking about Frank's comments, and for those of you on the webinar, because Design Interactive's headquartered here in Orlando, I had the opportunity to actually help recruit participants for this particular study because I work for the University of Central Florida. So that kind of explains the average age to some degree of a lot of the participants. But Claire, as you were conducting the study, and this kind of gets to the whole aspect of AR, the degree to which AR can be used as an effective training modality for folks, because I signed up to participate and I got bumped out because of I didn't pass the depth perception necessary for this particular study. So how many participants were screened and did not make it all the way through to actually participate in the full 2 hours? And how do those reasons that many of us got denied the opportunity, what does that say about the rollout of AR and how we think about it across military training and simulation, and taking into consideration the just existing physiological limitations of it being really effective?
So Carolyn, I believe the reason you sort of washed out, for lack of a better term, was the stereopsis test. Your depth perception was not as fine grained as what we had, what we were looking for in our study population. That's not to say that you can't see the virtual content. You very likely can. That's just an academic kind of research tool to screen out folks who might not be able to see the content or see it optimally. So we did actually have some questions on why so many people were washing out. And what we discovered is that there are about actually 8% of the population who cannot pass that stereoscopic vision test. So we were seeing about 8% in our screening. So that seemed to be relatively normal to the entire population, of the United States or whoever did that particular study. But that is certainly a limiting factor. We did have other folks who did not meet the acceptance criteria for the study. Mostly those were related to folks who were actually coming into the office feeling ill. So we had everyone take the simulator sickness questionnaire as a baseline to determine that, how they were currently feeling. If they scored a score of 12 or higher, we asked them to either come back another day or not participate in the study, because we wanted to make sure people were feeling well when they participated. So I hope that answers your question.
Yeah, I was just wanted to be sure we kind of address that issue, because I've been in other conversations where there have been questions about, all right, is this kind of technology right for training everybody, right? Or are we just adopting the technology without really thinking about?
And that's kind of the question we were looking to answer. Mm-hmm. Unfortunately, we weren't able to fully answer it as easily as we thought we would. It wasn't a one and done study. There are still questions out there, but hopefully we get the opportunity to run additional studies and learn more.
You studied 3 different headsets.
Yes. Two headsets and a tablet. And one of the questions that had been submitted ahead of time is, what are the 3 top determinants for the hardware itself as to what lessens these physiological effects and maybe what exacerbates them? So the differences, if that's what we're talking about, right? Differences between the head-worn displays. The 2 head-worn displays that we studied in this particular effort were the HoloLens 1 and the Magic Leap 1. At the time of the study, the HoloLens 2 had not been released yet. So the differences actually between the head-worn displays was minimal. We did see some differences, and I don't have all the data in front of me. We saw some differences in postural instability. It seemed like the HoloLens actually created a little bit more postural instability than the Magic Leap 1. That's possible that that's related to depth planes. So the HoloLens 1 and 2 only have a single depth plane, so your vision is fixed at the depth of the display. Whereas the Magic Leap 1 actually has a dual depth plane. It has an algorithm in it where it can switch between those 2 depth planes. Unfortunately, that algorithm is kind of a black box. You can't tell when it's switching. from either a user perspective or a developer perspective. So we weren't able to dig into that like we would like to. I do know that Magic Leap is coming out with their second iteration device. I would like to see that one and see how it works. Hopefully it's more ergonomically designed to fit better. I will tell you notionally that the Magic Leap one, the way it fit your head, pretty uncomfortable for participants. I saw many participants take that off after 20, 30, 40 minutes of exposure, up to 2 hours, with some pretty deep marks in their nose and their forehead where it's pressing in. So it's as the hardware improves and as we see how these things change, sometimes the physiological ramifications they certainly will change with hardware.
Are you, as a result of these studies or others, Frank, that you may know of that are engaged in these studies, are the hardware manufacturers asking about and engaging with you to learn what the results are?
So I can tell you that Vario and their XR headsets, they actually paid attention to some of our VR research. So we have a paper out there published by Frontiers called VR is Sexist. And that it kind of really goes into the details of the interpupillary distance and why it's different between men and women. And why that the head-worn display is actually, the way the head-worn display is manufactured makes a difference. So Vario, when they were developing their hardware, they took that into account. So they make a head-worn display with a fully variable range of interpupillary distance, whereas the headset that we studied in that particular effort was the HTC Vive Pro. Did not. It actually, the IPD did not go down far enough, and it really kind of excluded about 30% of women based on the IPD range of that particular headset. So some of them, yes, some of them, no.
And hopefully more will.
Yes.
Recovery, interesting data so far about recovery times. Has DI or others done studies about ways to help mitigate some of the physiological effect and shorten that recovery time, whether it's VR or AR?
So I personally no, but Dr. Castani has done some of that in the VR world. AR, not yet. This really was our first opportunity to dive into the world of AR. And matter of fact, when we were writing the proposal for this work, we did the research to see who else had studied AR, and there were, count them, one other research study who had looked at the physiological effects of AR specifically, and they had about 10 participants. So we really are kind of at the cutting edge of studying these AR pieces, and you know, we were hopeful that it would be a kind of a one and done. Oh, this is going to be easy. It's really benign. You know, take some breaks and you're fine. And that's just not what turned out to be the case. And so more research is needed here for us to really fully understand how these systems are affecting you.
One of the questions that was submitted ahead of time was about haptics, and particularly with tactical combat casualty care. So, and perhaps Frank, this may be something for you to comment on, is where does haptics, as it's increasingly adopted, fit in versus AR or in combination with AR?
I sure can. So I believe my feelings on haptics is pretty much right in line with Claire and the Design Interactive team. So haptics really does have a really good piece that's missing. I mean, we can do virtual reality and reach out and touch something that's not there, but when we don't get that feedback, that tactile feedback of what is supposed to be there, it loses that little dimension of reality. However, when we look at the haptics that are available today, they're very intrusive. So if we're going to do a surgical procedure or any procedure, if we're going to do something as minor as putting a tourniquet on and putting a tourniquet on, I guess, really isn't minor if you need one. But we don't do it with these giant boxing gloves on. We might have latex gloves on, but that's it. So if we put these giant boxing gloves on and do it, yes, we're getting some kind of tactical feedback or tactile feedback, but we're not getting as realistic as we would like, because we're not going to do that procedure in real life with those giant gloves on. So that really is the factor that we have to overcome as an industry to get rid of those giant gloves. And how we do that is yet to be seen. I mean, I've heard of neurohaptics, where we could affect the nerves in the arm to tell the brain that there's something there. I've heard about people looking at things where we can put a helmet on you and make your brain think you're touching things. But now that's years and years and years down the line. But when we look at the augmented reality world, we can put a mannequin or a person in front of you and superimpose those injuries onto that person and allow you to reach out and touch an actual human being or a mannequin with the augmented injuries on them that you're treating. So now you can reach out and do that log roll of that casualty, and you're touching a real 200-pound human being. That does add some kind of tactile feedback, but I think that really is the haptics area is really the missing link right now, because we don't have that ability without those giant boxing gloves. And like I said, I'm pretty sure that I'm close, if not right on, to Design Interactive's feelings on that too. Thanks.
You're absolutely correct, Frank. So we actually have another effort that we're currently working with STTC here in Orlando, and it's a haptics focused project. So what we're doing with that project is we have a subcontractor who provided hardware with synthetic tissue, silicone tissue, and we bring the AR piece. And with that, the AR scenario actually talks to the mannequin. So when you place the tourniquet on that mannequin with your real hands, right? No haptic gloves needed. We're using AR for this. You put the tourniquet on the mannequin, the pressure sensor detects that you've placed the tourniquet, detects that it's tight enough, and it sends a signal back to the HoloLens to say, okay, it's time to progress the scenario. They got the tourniquet on right, stop the bleeding, move forward in your treatment plan. So yes, haptics are something that we're interested in, and it's very important moving forward as we investigate these innovative digital technologies to not get too far away from the real thing.
Let's just touch briefly on cybersecurity issues or requirements in this training. We had a listener interested in what concerns there might be around cyber.
So our current solutions are all contained within the device. So there's no internet connection needed, so no real particular cybersecurity concerns there. I don't think we've really had the opportunity to investigate that yet, as we haven't produced a solution that requires it. So I don't really have a good answer for that one.
Well, it could well be that is a bigger concern if you're talking about use of AR, VR in an operational scenario as opposed
Absolutely
to a training scenario.
Absolutely.
As well. Yeah. What's continuing to be done? Obviously, Design Interactive's continuing to study in this area. Frank, I'd be curious if you know of other efforts out there, because this seems to be such a profound area of need to really understand what it's doing to us, right? As it's being rolled out, not just in defense, but every industry out there is increasingly adopting AR and VR technology to deliver content and experience.
I'm not aware of any other ongoing efforts. I'm very partial to Design Interactive's work, and like Claire said, that there wasn't much being done prior to the projects that they've worked on. So I believe it's 3. Claire can correct me if I'm wrong. 3 different efforts under the Appear umbrella to look at augmented reality and virtual reality from each of the different perspectives. So they've done a lot of work. They've uncovered a lot of different things that need to be worked on, and really revolutionized, I guess is a good word, the industry, and pointed out the things we have to work on. And organizations such as JPC6 with Dr. Fry, and then other organizations hopefully provide funding to assist in working down those avenues to do further studies, further research to accomplish these things and correct and prevent the issues which could happen with augmented reality and virtual reality. But outside of the work done by Design Interactive, I do not have any that I'm aware of that have done anything to the level they have. But like I said, I'm very partial to their work.
Mm-hmm. And I don't know if there is any work going on in some of the other industries here in Orlando. We're the home of a somewhat decent size entertainment industry, which is very technology innovation focused and increasingly utilizing these technologies, as well as in education and other areas. So, and the mental health application that Paul's commented on in the Q&A, certainly he's correct that VR in particular, I know, has been increasingly used for overcoming anxieties, PTSD, other forms of anxiety disorders. I know here at UCF, University of Central Florida, there's a substantial amount of work going on that DoD is funding as well. So yeah, a lot of perhaps information there too that could be utilized here. So where does this need to go? And Claire, Frank, what could you use in terms of whether it's input, feedback, collaborators, customers? What do you think would help move this whole field forward?
Frank?
I guess the easy answer there is money. Money is the root to everything, and nobody can do research without the financial backing to make it happen. There's a lot of research that needs to be done. In this study in particular, Claire pointed out the differences between men and women when we talk about AR and VR. And I personally think that's something that we should invest time and money in to explain why there's a difference between men and women in this area. And unfortunately, that's the case in multiple other areas. There's work that's been done. I believe it was somebody from STTC that actually published the paper on women having a much poorer outcome from traumatic injuries in combat. So a man could have the same injury as the woman, and the woman has a greater chance of dying just because she's a woman. So unfortunately, there's male to female discrepancies in a lot of areas, and augmented reality and virtual reality are one of them. And I think that's something that does need to be pursued a little more to figure out why and see if we can correct why. But without financial backing and without money, it's hard to do those things. So I think that is the greatest thing that we can find to move forward.
Yeah, and I'll piggyback on what Frank is saying there as well. End user participation as well. So we ran this study here in the local Orlando area using local participants. Not as many military folks as we would have liked. The next step, if we're really talking DoD, would be to test some of these things, on actual using actual military folks to really represent that right population. Whether that's in the lab or in the field, we certainly can travel with all of our testing equipment. It can be set up anywhere. So if folks inside the DoD are interested in understanding these physiological effects of their technologies that they're already using, or technologies that they're considering using, we're happy to take these things on the road.
An interesting question about the integration of artificial intelligence into VR and AR. And you aware of anybody that's looking at that? I could see a scenario where, based on a particular individual's physiological, medical, mental, all sorts of assessment profile that AI could be utilized to help individualize the training a little bit to reduce some of those.
Absolutely. Absolutely. And that is something that we are looking at. I'm sure others are looking at it as well. So one of our current efforts that we're working, and I cannot recall off the top of my head who is funding that, but it's an effort called Asclepius, where we're looking at computer vision to determine whether someone has applied a tactical combat casualty care intervention correctly. So we're using that computer vision within the AR headset to look at what's been done to a casualty or a mannequin in this particular case, and determine whether they've applied those interventions and or correctly. So yes, that's definitely something that we're interested in, that we're looking into in various forms. We have another suite of products that's called Augmented, where we're using some back-end AI for determining what lesson you receive next. So based on your performance in the previous set of lessons, what level are you at, and are ready to move forward there. So yes, AI and AR and VR, these technologies are very interlinked and will continue to be as we move forward into the future.
And I assume that question stemmed from Mr. Vallejo, which I'm watching it come up. So that there are other companies that I'm aware of, and I don't know what the rules would be about disclosing who they are and what they're doing, but the augmented reality, virtual reality, and integrating artificial intelligence, I know there's a couple companies that are looking at taking real information from that individual. So their health component, their physical abilities, their performance in the medical tasks or the soldiering tasks, and integrating that into their scenario. So they could only, just like playing a video game, in a video game, everybody's invincible, everybody can run as fast as the next person, but it's not the case in the real world. So in this particular effort, they were taking all that into consideration. So now in the virtual reality scenario, if you're a person that can't run so fast or you're vertically challenged, you might not be able to make the same movements as everybody in your squad, or jump that fence, or get to that casualty as quickly as everybody else. So artificial intelligence is making that happen. Now, I have not seen a lot of the work, but I've heard about that particular work in calls such as this. So I believe there is some work being done there, but that's the perspective I could offer in there.
Thank you, Frank. And next question, Frank, you probably have a little bit better perspective on this, but since tactical combat casualty care has been mandated across all the services, and we see it's being rolled out in a number of different ways. I know there are other companies that have developed training modalities for TCCC. Do we have any feel yet for which type of training we're seeing the most effectiveness with, or is it a matter of what's most predominant right now in how it's being used?
I can't quote any specific research study in that area, so I can only give my perspective on it. But when we talk about augmented reality and virtual reality and how it applies to tactical combat casualty care, it's my belief that the knowledge, the actual need for doing it and why we're doing it is enhanced by augmented and virtual reality. And going right back to the haptics question, we might not be able to reinforce the hands-on part, but we definitely can reinforce the cognitive standpoint, the when to do it, the why to do it, the how to do it, but not necessarily the actual act of doing it as clearly as would be required. Now, like Claire referenced with using mannequin that can give feedback to the lens, I think that is bridging that issue that we have, that disconnect between the mind and the hands, where once we can get the how and the why in the brain, and then the actual doing it into the hands, to get that motor response, that cognitive and that tactile feedback together, is going to make things work so much better. But that's, again, my opinion, not a study that I'm quoting or anybody's information that I'm quoting, just the opinion of Frank.
And in this webinar, the opinion of Frank is highly valid. Thank you. Well, some of the other questions we have get really into pretty technical aspects. And Claire, you've been wonderful about answering a lot of those questions on the Q&A. So I thank you for that. We are going to, I think, go ahead and wind this up. I'll give Claire and Frank a chance to make parting comments. But before that, I will make sure you're aware that this webinar is being recorded in anywhere from 24 to 48 hours. It will be available for viewing on the NTSA website. You go to NTSA events page, go to past events, which is over on the right-hand side there on the screen. You pull that up and you'll be able to see not only this Tech Connect webinar, but all of their webinars, which including the previous Tech Connects that we have done. Give each of you a chance to make any final comments or remarks. Claire?
I'll just thank you, everyone in the audience, for joining us. We really appreciate the opportunity to discuss these research efforts. I'm pretty sure my email address is somewhere associated with the webinar. So if you have more specific questions, or you're interested in any of the measures that we used, or any additional information, just feel free to reach out. Happy to answer any questions.
Thank you. And Frank?
And thank you to Frank for joining us as well.
Yes.
We really appreciate your help today.
Absolutely.
Thank you for the invitation, and thank you for the opportunity to do this. I'm just very happy to be involved in efforts such as this and continue to make impact and provide for learning and care on the battlefield. I mean, now that I am retired from the military, I'm not providing that active care, but in my case, the rewarding part is staying involved in the training, because then I am still being reflected in what's being done overseas. And that's very important to me, because less blood in training is definitely less blood on the battlefield. Thank you very much.
Thank you both. And one last admonition for those of you that have been able to remain on: please follow the Central Florida Tech Grove LinkedIn page so you can find out about all of our events going on. With rare exception, they are offered in a hybrid format, so you can attend virtually if you're not here physically in the Orlando, Central Florida area. Please fill out that contact us form on our website, centralfloridatechgrove.org, so that we can have your information and send you more detailed information even about upcoming events, but also opportunities where we are putting out calls for solutions and capabilities, because our customers do task us to help solve some hard problems and go look for existing solutions and capabilities in organizations, whether it's academia or companies that may have really interesting capabilities to help solve those problems. Thank you so much for joining us. I hope you will join us next month on the third Thursday of August. Stay tuned to hear more about what we will feature there, and hope you all have a great weekend. Thank you so much.